Okay, hopefully you've had a chance to try the 10 practice problems. And again, we're calculating and then rounding our answers to an appropriate number of significant figures. Here in number 1, keep in mind the rule for addition and subtraction. We're going to round to the fewest number of decimal places of any of the numbers we're operating on. So we're adding these two numbers. If I do that mathematically, 2, 0, 16, carry the 1, 13, carry the 1, 2, 23.602. I need to round this to one decimal place. The 8.9 only has one decimal place, so that would round to 23.6. And that's my answer for this problem. In number 2, the rule for addition applies. Since we're adding, round to the fewest number of decimal places. Both numbers have 3 decimal places, so we're going to round our answer to 3 decimal places. When we add 7 plus 5, 12, carry the 1. 1 plus 1 is 2. 0 plus 9 is 9, decimal point. 8 plus 4 is 12, carry the 1. 1 plus 1 plus 1 is 3. And then 132.922 centimeters is the answer. For number 3, the same rule applies. We're subtracting, so we're going to round to the fewest number of decimal places. We have 3 decimal places in each number, so we'll round our answer to 3 decimal places. Let's do it. We'll borrow a 1 here, so 10 minus 3 is 7. 1 minus 1 is 0. 3 minus 1 is 2, decimal place. 9 minus 1 is 8, and 2 minus 2 is 0. So our answer for number 3, 8.207, rounded to 3 decimal places, just like both of our numbers here. We're subtracting, so the same rule applies. We'll round to the fewest number of decimal places, which here is 2 decimal places. Subtract 0 minus 4. We'll borrow a 10, so 10 minus 4 is 6. This becomes 1. We'll borrow a 10 again. 11 minus 9 is 2. Borrow another 10, so we have 10 minus 1, which is 9. This then becomes a 7. 7 minus 1 is 6. And 3 minus 2 is 1. Again, we're rounding to 2 decimal places, so this should be rounded up as our final answer to 16.93 meters. Again, 16.93 rounded to 2 decimal places. The final addition subtraction problem, we're adding this time. Same rule, rounding to the fewest number of decimal places, which is 3 in this problem. Both numbers have 3 decimal places. So here we go. 7 plus 3 is 10. Carry the 1. 7 plus 2 plus 1 is 10. Carry the 1. 6 plus 1 is 7. Decimal point. 2 plus 1 is 3. 4 plus 1 is 5. 53.700 grams. Now in this problem you may be tempted to simply write 53.7. However, because of our rules about significant figures, you do need to include these final 2 zeros. Both of our measurements measured out to the thousandths place, this 3 and this 7. So our final sum needs to reflect these 2 measurements. So even though we end with 2 zeros, that's our way of saying that we can be certain down to the thousandths place that that's what our measurement is. 0 hundredths, 0 thousandths grams as part of our measurement. Number 6 is a division problem. The rule is that we round our answer to the fewest number of significant figures in any of the numbers we're operating on. Both of these numbers have 4 significant figures, so we're going to round to 4 significant figures. Now when you do the work on the calculator, if you look at the bottommost number there, that's what we get on the calculator, 2.9296, whole bunch of decimals. That's not really what we've measured. We haven't measured out to the billionths place. We've only measured here to the hundredths place. So what I'm going to write down as my answer to 4 significant digits, 2.930. The 29 that was here rounds up to a 30, and that would be grams per cubic centimeter. That's a measurement of density. So that's my answer for number 6. Number 7 is multiplication, so we'll do the same and round our answer to the fewest number of significant figures, which is 3. This number has 3 significant figures. Zeros to the right of non-zero digits, if there's a decimal point present in the number, they are significant. 3 sig figs, 4 significant figures. We're going to round to 3 significant figures. I'll do the problem on the calculator, and when I do so, I get this number, but again, I want to round that to 3 significant figures. So to do that, 3.16, and that's square meters. So my answer rounded to 3 significant figures, 3.16. Number 8 is division. 2 significant figures is what I'll round to here. This number has 3 sig figs. Sandwiched zeros, zeros between non-zero digits, are significant, 3 sig figs. Zeros that are to the left of any of the non-zero digits in the measurement are not significant. You do need the zeros there, but we don't consider them significant. So my answer will be rounded to 2 significant figures. On the calculator, this is what we get. Very long number there, a whole lot of decimals. But again, we didn't measure that precisely, that accurately. So to round, I round that to 1.3, and that's grams per liter as my units. 2 significant figures. We're multiplying, and again, the rule, we're going to round to the fewest number of significant figures. This one may seem a bit tricky. 4 significant figures in this number. This number is an exact measurement. We can know exactly that we have 6 beakers, and it only has 1 digit to begin with. So we have 1 significant figure in number 9 that we're rounding to. On the calculator, you get this number, 312.66. To round that to 1 significant digit, we would simply write 300. The 312 rounds down to 300, and we would write that without a decimal point. Keep in mind the rule that zeros to the right of any of the non-zero digits in the measurement, if there's no decimal point written, those zeros are not significant. They need to be there as placeholders. This is 300 grams, but they're not considered significant. So 300 grams is your answer for number 9. Okay, finally in number 10, we're dividing again. So we're going to round our answer to the fewest number of significant figures, which would be 3, representing the 3.38 liters. On the calculator, I get this large number, again going out to the billionths place, but we're not measuring to the billionth of a gram or to the billionth of a liter. So I need to round that to account for significant figures. So 3 sig figs, 2.80, and that's grams per liter. So 2.80, that's 3 significant figures.